Okay, good afternoon, students. This is going to be the method of adding vectors analytically. And when we say analytically, this time we're going to use math instead of geometrically. Just a quick review. If you remember in the previous lesson, we were going to add two vectors geometrically. We would add them tip to tail. And notice that that is the tip. That's where the arrow tip is, and the tail is down at the very end, so that part is called the tail. And if we're going to add those two vectors together, we would just translate it, or that means we can move it parallel. So we're going to take this vector, B, right here, and we're going to move it right up there and attach it right onto A. So here's B, and we attach it onto A. And again, we just moved it parallel. And to get the resultant, we're going to start where we began, right there at A, and we're going to point to the finish, which is right here. So this would be vector C, which is the same as vector A plus vector B. So what if instead of adding A plus B, we wanted to get A minus B? Okay, well, A minus B is the same thing as adding A plus the opposite of B. So we would take vector A, draw vector A, go in this direction. Notice B is pointing in the northwest direction. So if that's the case, then we just turn it around 180 degrees, go in that direction. Notice we just flip the vector around, and that's minus B. A minus B, and then to find the resultant, again, start from the tail of the first and point to the finish. So vector C would be A minus B. Okay, vector A minus vector B. So in the next section, we want to start adding vectors analytically, and that's using math. So let's suppose we have two vectors. And these two vectors are 4 meters east and 3 meters north. And we want to add those two vectors together. So the first thing I'm going to do is just make the sketch. And so I've sketched those two vectors. But I'm going to change color here and show that the resultant is going to be pointing in a northeasterly direction. Well, how are we going to calculate that length of that vector? Well, we're just going to use the Pythagorean theorem that you're used to. You know that the Pythagorean theorem was c squared is a squared plus b squared, okay? Or c is going to be the square root of a squared plus b squared. Okay? So in this case, our vector A is 4 squared, and our vector B is 3 squared. And if we add those together, we're going to get 16 plus 9, which is going to be the square root of 25. Okay, and that's going to give us a magnitude of 5 meters. Okay, 5 meters, and it's going to be pointed at a northeasterly direction. So one other thing we want to do is we want to find out what is the direction, what is the angle that this vector is pointing. So in order to find the direction, we're going to drop back on our trigonometry that we've learned, and I want you to remember SOHCAHTOA. And if you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what we're looking for is we're looking for this angle here from 0 degrees. Remember, going around counterclockwise is always positive. So we want to find out what is the angle between the 0 degrees here and up to our new vector. So we have opposite side, we know, which was 3 meters. And we have the adjacent side, which was 4 meters. So we want to find the angle there. So we're going to say, well, the angle is just the inverse tangent of the opposite side over the adjacent side. Remember, tangent's opposite over adjacent, so inverse tangent would be would give us the angle that we're looking for. So theta equals inverse tangent of 3 meters over 4 meters. And if we carry out the arithmetic correctly, the inverse tangent of 3/4. That's 3/4 or 0.75 is going to give us about 37 degrees. So the angle would be 37 degrees from 0. So that's going to be 5 meters at 37 degrees. So let's take one more vector analysis problem while we're adding in perpendicular. We have one vector that's going to be going, let's say, 115 meters west. And then we have another one that's going to be going 136 meters north. Okay, and we want to add these two vectors. So the first thing we do, of course, is we make a sketch. So we're going to sketch it out first. Then we're going to sketch our resultant displacement. So the resultant is from where we started to where we finish. So there's our sketch of our vectors. Now, the next thing we do, again, they're at right angles to each other, so we're just simply going to use the Pythagorean theorem, okay, and that is c squared is the square root. We'll let this be vector A, and we'll let this be vector B. So that's going to be the square root, 115 squared plus 136 squared. And I'm going to let you take a second to pause and calculate that on your calculator. And you should get about 178 meters. So the resultant there would be 178 meters in length. Okay, now the next function we have to do is we have to find out, well, what is exactly the angle? And it's before the angle. We're going to let this be the angle here, because this is going to be, letter B is going to be our opposite side. Letter A is going to be our adjacent side. So we're going to find the angle there. And let's go back to the inverse tangent function. Theta equals the inverse tangent of the opposite side over the adjacent side. So that's the inverse tangent of 136 meters over 115 meters. So let's do the arithmetic. And if you do the arithmetic correctly, you're going to come up with about 49.8 degrees, or we can just say 50 degrees. Now, the 50 degrees is between the negative x-axis and the angle there. So what we're going to do is this. We're just going to subtract 50 degrees from 180. Okay, because what we always like to do is we like to go from our 0 all the way around here. Okay, so we can start here. We can either go 50 minus 180, because this is 180 degrees, which we know is going to give us 130, or we can start from 90, go from 0 to 90, and then add 40 more, which is going to give us 130 degrees. So our answer will be 178 meters at 130 degrees. And I want to make sure you understand why it's 130 degrees. It's 50 degrees from 180, which is here. Okay? But what we want to do is we want to measure from the 0 degree mark. So we'll go all the way up to 90 and then all the way around to there.